Hi everyone, my name is Dmitry Figo and today we're gonna do Troubleshooting Lab. This lab was originally designed by Andre Laurent specifically for his webinar session. Unfortunately, we did not finish it in time during the webinar, so he decided to share it with the audience, and I decided to record a step-by-step video tutorial explaining my every step, how did I find the problem, how I solved it, etc. But before we start, let me introduce myself, like in brief. So as I told you, my name is Dmitry. I am CCNP in routing and switching, not CCA yet, but I'm slowly working towards it. I really like networking, especially troubleshooting, and I also like programming, and sometimes I like to do some cool stuff and solve some networking problems using programming languages. Alright, now let's jump to the lab. As you can see, I'm using SecureCRT, not multi-tap PATI as it was offered by the lab. How to set it up I described in the post-seminar discussion thread on the forum. So here it is. So you will also you will find link below the video, and in this thread there probably will be recording soon of the webinar. There is PDF with tickets, and here below that I described how to set up the terminal emulator of your choice to connect to this lab. Okay, now let's jump to the lab. Here is the topology, here is tickets. Just let me say a couple of words about the topology. There are 6 routers and 1 switch, which is not shown here, but basically all routers are connected to it, and using so-called router on stick design. So we create sub-interfaces on routers and assign VLANs to them, and then we can build any logical topologies we want on this one link without recabling our physical topology. So it's really neat, it's really simple, and you can build whatever you want on the same physical topology all over again. Alright, let's jump to the tickets. So here we have 6 tickets. Of course I read through them once before I start doing the lab, and we will do in the order, but I want first to take into account that point. So we should not modify configuration for routing protocols other than EIGRP. Yeah, so the first thing I would do, because topology is really small, I would investigate what routing protocols we use. So to do that, we will use show IP protocols command. Let me do this. This is command window, and I will send this command to all routers. Right? So I do show IP protocols, and let me filter the output out. So I will do pipe include and a routing protocol. Right? And you see here is a small delay between when I time and when it appears on the console. It's because I currently reside in Europe and the lab is hosted in the US. So I'm sorry for that, but it's really nothing I can do to solve this. So on router 1 we have routing protocol EIGRP 100. Router 2 we have EIGRP and RIP, so please take that into account. On router 3, So let me do this. E router 3 we have, sorry for my drawing, we have here E. On router 4 we have EIGRP E. On router 5 we have no EIGRP but RIP only. RIP. On router 6 we have EIGRP. Alright. So it seems that on this portion of the network we have EIGRP, and on these two routers we have RIP. Let me go to router 2 and to show IP protocols to show more output. I will go to the very end, routing protocol RIP. I'm looking for routing information sources, and here we have 10.1.25.5, so basically this address. So these two routers are RIP neighbors, so it seems that here we have RIP. What else we have here? We have redistributing EIGRP. So from EIGRP to RIP we have redistribution. On EIGRP, under EIGRP 100 we have redistributing RIP. So we on router 2 we have two-way redistribution in one point on router 2. So I will clear this diagram right now, but I will take into account so that on this link we don't run anything. That here we have RIP, here we have EIGRP, and here we have redistribution. So let me clear this out. So it's really important to get familiar with topology, and depending on situation you are, you probably will have some diagrams with like routing protocol design. If you are like on CCA Troubleshooting Lab, probably you just won't have time to get familiar with topology because you need to solve tickets as fast as you can. But depending on the scenario, probably it still would be nice to some show commands on relevant devices before you start to go deeper in troubleshooting. Alright? So let's jump to the first ticket. Make sure router 6 learns specific routes for prefix ranges that exist on R5. Alright, so R6 should learn about like this, maybe this. Let me go to R5 and let's verify what prefixes we should learn about, right? So I will do show IP interfaces brief. Here we have 10.1.25.5, 5555. And see here we have 5555 two times. It is because it's so-called IPN number, so on here on serial link we borrow this IP address of another interface. We have 55.55.55.1. I don't see other IP addresses, like here we have from 1 to 10. I don't see 2, 3, 4, 5 until 10. So it's because they're configured as secondary IP addresses. Let me show you this. So I do show run pipe include interface or IP address, and you do like this IP. Alright, so here you see we have loopback with /32 mask, and that's what I was talking about. So we could configure as many IP addresses as we want as secondary on the interface. So we should learn about these prefixes as /32. We also should learn about this /24 prefix. And here you see we have IP numbered, which is from loopback 0, which is 5455. Alright, so let's go to R1 and check what we learn now. Right? I do. Sorry, on R6. Show IP route. I see some EX routes. 1, 3, 6 loopbacks. I also have some other routes coming from 1. I don't see any 5555. I don't see 10.1.25. I don't see 55. So clearly there is problem there. What else I can gather from this output? You see there are no nothing is learned from R4. So it's really strange. So we have nothing from, sorry, it's in the other direction. So from R4 we learn nothing. So it's strange, but while I'm on this ticket, I'm not sure whether they should have some neighbor relationship or not. Maybe they are not supposed to be neighbors in the first place, right? So, and again, we learned some routes from R1, so it's really important point. So after this output, the next thing I would do, I would go to router 2 and I would verify redistribution, because it's very usual problem where the distribution is broken, because for EIGRP you have to set a seed metric. So let me check this. Show run section router, and here we have redistribute RIP with metric, so that's alright, and redistribute EIGRP with metric 1 into RIP seems alright too. I would not recommend you to do this in any scenarios except lab, because the resulting metric from this is very high. So let me show you. So I will do show IP route, and I'm looking for what? I'm looking for 55 prefix. Oh, sorry. On R2, this routes are learned via RIP. Okay, so these routes are learned. So they, if they appear in the routing table, we could distribute them. It's good sign. If they don't, we can't redistribute. So let me look into EIGRP topology table. Show IP EIGRP topology for 5555 to 55 to 55 to 55 to 55, and that's what I'm talking about. So 3, 3, 3. So 2.5 million K, 2.5 million is the metric. Sorry, it's not. It's billion. 2.5 billion. So it's really high metric, and actually for the routing table there is like upper limit for this value, so you could exceed the maximum value. I believe it's 2 to the 64. Let me check what the value is for to the 64. No, I believe it's lower number. I believe it's this. It's 32-bit number, so it's 3. It's 4.2 billion. I'm not sure about this number, but probably it is. So it's maximum metric available, so that routes which exceed this metric won't be installed in the routing table. And it's really the issue if you switch from a so-called EIGRP classic mode to the named mode, because by default the resulting metric is different for EIGRP named mode, so it's really an issue. So I wouldn't do that at all. So it's not necessarily the problem, but let me change this metric to so that this value will be lower. All right. So I will do show run section router EIGRP again. I will disable this router EIGRP 100. Oops, sorry. Router EIGRP 100, and I would do this no, and I will redistribute RIP metric, and I will give 100 kilobit per second or 1 megabit per second, and maybe delay 200, maybe 255 reliability, 1 watt loading, and 1500 MTU. Let me verify this. Oh, sorry. So you see now the metric is much more lower than it was. It's now it's 2.6 million, and it was 2.5 billion, so it's much more lower. You also see this. I show run section router. Yeah, I should delete this process. Conf T, no. Alright. Let me go to R6 and verify if the problem is fixed. Show IP route. I still don't see any redistributed routes. So clearly there is a problem. So we know that R2 runs about these routes. Let me go to this, to R1, and I will do this. I will show IP route, and let me start from 5555. You see we have this route from router 2. Metric is alright. Okay. So let me show IP route pipe include DEX. You see we have this link between 2 and 5, we have 55 routes, we have 5555, so it seems alright to me. So you see then on router 2 we also see the specific prefixes. Now let's go to R6 again. Now what else could it be? There could be summary here in this direction, maybe default route, but I don't see the summary, so like 0000, so it seems there is not. What else it could be? There could be outbound, like distribute list, outbound, out, or here on R6 inbound. So let me check this, and also we'll verify some access lists. So let me go to R1, show IP access list. So nothing is there. Let me do this show run section router. I also don't see any distribute list, so it seems alright to me. Do the same thing on R6. I do this. so we don't have any access list. Here we have distance, but it's not distribute list, so it's not the problem. So there are no some inbound or outbound distribute lists. So strange. Let me show you this again. So there's a routing table opened on R1, and you see that we learned some routes from 1, but not the routes, this external route. So, and to solve this problem, you really need to know this like feature in the EIGRP, because if you never heard of it, you won't solve this problem. And also this problem is, in my opinion, one of the hardest one among all the problems that I encountered with, because it's really hard to troubleshoot it. There are not so many like show messages or debug messages to find out what's wrong. So and I knew this because I already encountered it in one lab like 2 years ago. It was also a EIGRP lab, and I learned this feature from it. And actually my first article was exactly about this behavior in EIGRP. So what is the problem? So it's loop prevention mechanism built into EIGRP for external routes. And it says this. We don't accept any updates for the specific prefix external routes if originator router ID equals to our own router ID. And it seems not so easy to understand, but it's actually very easy concept. Let me show you. So in this scenario we have R2 as redistributing. So in the update for this external routes, it includes his router ID as like originator router ID. Let's say this update will lay bounds will go to router 1, go to router 4, go to router 3, and come back to router 2. And to disable this loop, to like don't accept this update, router 2 says this. Okay, so in this update, originator router ID equals to my own router ID, right? So we should just drop this, ignore this route, ignore this update with this prefix. The problem is that, as I told you, it's really hard to troubleshoot. There are no logging message. There's only one command that some time ago, maybe in 15.1 and 12.4 code, it was hidden in iOS. Now it's not hidden. So let's go to R6. Let me show you this. Very important and very command with a lot of useful output. It's called show IP EIGRP, and this is it, events. So as I told you before, it was hidden. Now you can use it. Well, you could use it before also, but it would not specify under the question mark. Show IP EIGRP events. And you see this, ignored route. 55 prefix, .7, .8, 10.1.25. So, and what does it say? Dup for duplicate router ID internal, which is ourself, and external, which is originator router ID for this prefix. So it seems that router 6, let me clear this output. Router 6 has the same router ID as router 2, because router 2 was originator of this prefix. So R6 receives this, compares router IDs, finds out that they're equal, so it drops the update. There are several ways to find out EIGRP router ID. So let me do this. Show IP EIGRP topology pipe include ID. You see here we have pipe 6666. Do the same command on router 2. Oh, sorry. I ran that command on all devices. So on R2 we also have this router ID. So why? I would go to the running configuration to verify if it was set manually. Show run section router. Here under EIGRP I don't see EIGRP router ID statement, right? So the next thing would be to verify IP addresses. Show IP interfaces brief. And you see here we have 6666 loopback. I don't know why. So when this loopback is clearly loopback of R6 on the according to the diagram. So let me change this. So let me shut this loopback down. Interface loopback 6 shut. Let's do command again. See, ID has not changed because we have to either reboot route or reset router ID manually. And actually setting router ID is the best practice for any routing protocol manually. So I would encourage you to do that after this tutorial for any labs that you're doing. Like if you use OSPF, EIGRP, BGP, the first thing you should do is set router ID manually. So router EIGRP 100, EIGRP router ID 2222. Right? Okay, now it's changed, right? And you see that neighbors are reset automatically. Let me do this one more time. ID 2222. Alright, let's go to R6 and we do show IP route. Pipe include DX. And see, now indeed we learn about 5555, 55, 10.1.25. So it seems that for me that this problem is solved. So we learned specific prefixes. So let me put this. I also will write down our solution. I like to, not that I like, but it's a good thing to document what you did in order to resolve your problem, and so that you could revert back your changes. So it's ticket 1 on R2 interface loopback 6 shut, and router EIGRP 100 EIGRP router ID 2222. Alright. Okay, so we fixed this problem. Let's go to the second ticket. R6 should be able to telnet to 1111 over both available paths. Alright. Let's go to R6. So let me go to the diagram first. R6 should be able to telnet to 1111 over several paths. So I would assume that we should go like this way, it may be this way, or this way, something like that. Right, so let's go to R1 and verify what we have right now. R6, sorry. First we would ping 1111, and indeed we can ping. Right, can we telnet? And see it's stuck, so usually it means that we can't telnet. Right. Let's wait for the output. It should finally realize and give us some reasonable output. Okay, connection timed out, remote host not responding. Alright. So, what could it be? No, let me do trace route first. 1111. So we go directly through this link. Alright. What it could be? It could be that on R1 we could have some access list inbound here or on LAN VTY. It could be some problem with telnet configuration. So let's check it out. I like to do first show IP access list. We don't have any. Nice. Let me do show run section line VTY. So here we have transport input none, so we did not enable telnet, so this clearly is a problem. Let's fix that. Conf t line VTY 04 transport input telnet. And this we should either set password when we use login, or we could do no login. No login, right? And let's try telnetting again. Seems it's stuck again. Right, but remember that we can ping, we can trace route here. So what else could it be? The next thing to check, I would go to R1 and I would debug this. What we will do, we will create, so there are some EIGRP packets running here, so we need to filter this output, right? So I would create access list specifically for Ethernet, access list 100, permit TCP any equal telnet, and I would do debug IP packet detail 100, right? Go to R6 again, connection timeout, remote host not responding. Let me telnet again. Go to R1 and I will clear this debug. What does it say? So we have here packet incoming with source 6666, destination 1111, right? What also we see here, packet routing is failed, right? So this is strange. Why? Because when we telnet and when we choose this link to go to 1111, we should use this IP address, right? Not 6666 by default. So this is strange. And also you can see here that we have packet routing failed. What does it mean? It means that we received packet, we processed it, we want to send a response packet back to 6666, but we don't have a route to it, right? So let me show you this. Show IP route 6666. We don't have this route. Show IP route 0000. We do have default route. but it goes in the another direction. It goes here, right? So this is clearly wrong. So first of all, why we choose 6666 as our source IP address for telnetting? So there is command on R6, probably. Let me verify. Show run pipe include telnet. This one. IP telnet source interface loopback 0. It says, okay, let's for all telnet session, let's specify source interface as loopback 0, as 6666, right? So probably we could remove this command, but during troubleshooting I try not removing anything until it's very necessary. So let's fix routing. Why we could fix routing, right? So why 6666 does not announce this prefix to R1? Why? Well, there could be different reasons, but the first thing to check would be running configuration. Show run section router. And we see here network 10.0.0.0, but we don't see network statement for this one. We could either redistribute connected or include network this IP address in the network statement. And let me do this. I don't like redistributing because we will have routes as external, and I don't like to do that unless it's really necessary by design. So router EIGRP 100 network 6666 0000, right? This should potentially fix our problem, right? Let's do telnet again. Now it's working. Very good. Right. So I would first document my changes. On R1 we did line VTY 04, no login, transport input telnet. And on R6 we did router EIGRP 100, network 6666 0000. Right. Let's go to R1. I will show IP route again, show IP route 6666. And indeed we learned this route from R6, as we expected. Alright. The next thing to do. Now we should disable this interface, and we should be able to reroute like this or like this. I don't really care, but we should be able to reroute. Okay. So on R6 conf-t interface 0/0.16, shut that down. Right. Let's meet first ping to 1111. Not good, right? So let me show IP route to show routing table. Wow. So now we don't learn anything. So except of our connected interface. And you see from this output there's something interesting here. We only see our loopback 0, but we don't see even this link. Alright, so let me do this. I will do show IP interface is brief, exclude unassigned. Wow, so this interface was down. right? So let me enable it. Interface E0/0.46, no shot. We see neighbor. Let's look in the routing table again, show IP route. We learned only default route. Wow. 2 4. Let's ping again. Ping 1111. We can ping. How do we get there? We go to 4 and 1. Nice. And can we telnet? Telnet 1111. We can. Right, so we fix this problem as well. So we can telnet like this. If this link goes down, we can reroute like this. Very good. So we check this, and I will all set to my answers here on router 6. We do interface E0/0.46. No shot. Alright. What else? I should enable this link again because we disabled it. Not really good, right? conft interface E00.16, no shot. And let me verify this. Okay, we have up. Seems alright. Can we telnet again? Just to make sure. And we can telnet again. Very good. We fixed 2 problems. The next one. R6 should leverage primary default route to next hop 10.1.16.1 and secondary route to 10.1.46.4. Alright. Let's first look at what we have now. Do we have default route at all? And we have, so we have default route coming from R4. I don't see any default route from R1, but let me show it like this. Show EIGRP topology 0000. Okay. All links. No, incorrect syntax. Like this, all links. Okay. I still see only one successor, no alternative paths. So what we could do? So on router 6, I remembered one command that was used, show run section router. You see here distance 89 for this neighbor. So by default EIGRP distance is 90, so routes coming from here will have AD 89 and here we'll have AD 90. If they correspond to the same like prefix, we will choose this one. So, and it will solve our problem actually. So the simplest solution I see this, we could announce here summary default route here. We have one from here. Sorry. So we have from here, we don't have anything default route from here. So I will do summary here on R1, right? Let me go to R4 and to verify if there is indeed summary configured like this. I do show run what? Show run pipe include interface or EIGRP. And you see indeed we have a summary on this link in this direction. So I will do the same thing here. Why not? Let's go to R1 conf t interface E00.16, and I will do this IP summary EIGRP 100 0000 0000, right? And I will go to R6 and I will show IP route. Wow. So now you see we have default route pointing to R1, and I don't see route pointing to R4 because, as I told you, there is this distance 89 versus 90. 89 is preferable. I believe now we could see both directions in the show IP EIGRP topology. All links do like this. See, indeed we have two paths, so it seems alright. As test, let me do this. Let me do telnet again. No, trace route to 1111, and we go directly to 1. Again I shut link down 16 shut, and I do trace route again, and now we go here, link is shut down, we go here and we show IP route EIGRP. We see we have default route pointing to R4. So really easy problem from my perspective. So let me document what I did. 3 on R1 interface E00.16 IP summary address EIGRP 100 0000. Alright. And we should not forget to enable interface again. No shut, and I will do again show IP route EIGRP. Now you see we have route from R1. Problem solved, very easy, good. Must be able to ping from R6 6666 to 5555 and 555555.1 while making sure to take paths from R6 to R4 to R3 to R5. This is a little bit tricky, and let me explain to you why. We have default route like this, which is preferable, and we have another default route like this, which is less preferable, right? Because of problem 3. But we must be able to ping from R6 to these addresses via path like this. Sorry. Like this, right? But we prefer default route like this, right? So there are several different solutions to this. we could do policy-based routing on R6 to make sure we go that way, but I don't really like policy-based routing unless it's like really necessary, because it's really hard to troubleshoot it. It's just, you know, it's like last stage effort, like hack, and you should not do it unless you have another way. And here we actually have another way. So let me show IP routing table again. So we learn only default route from both directions, no specifics, right? Right. What we also did, it's really interesting. When we did point 3, our point 1 became invalid. Alright, so we don't have any specific routes again. There is one very nice feature in EIGRP called EIGRP Leak Map that will help us to do that. What does Leak Map do? So in summary, when we do summary, we suppress all specific routes by default. So when I announce here summary, we don't see any specific routes. What leak map allows us to do is that we could leak specific prefixes along with summary. So here we will announce 0. Let me use this. So we will announce 0000 /0, and it's the only thing we announce by default with summary. But with leak map, we could leak other prefixes as we want. For example, 5555 or 10.1.25.0, so that we will fix the first point and we will help us to solve this fourth point. And I will do that on router 4 because we need to route in that direction, right? So when we leak these specific routes, so here we have default routes, default route pointing to this 0000, and here point to specifics, right? All right. All right. How should we do this? Let's go to R4 and let me repeat this configuration, and I will add leak map. You see, I do question mark, there's leak map, and we need to specify route map. So we name it like leak, right? Right. So now we exit and we do route map leak, and we will match. No, let me do this first. Let me define IP prefix list. R5 subnets. Okay, and I need to permit permit 5555/32 yeah, right. let me do this in the text editor, right? So I will just show IP alias here. I will gather these IP addresses, go to my text editor. I will do like this. IP prefix list R5 subnets permit and here is 24. Right, go back to R4. Right, and do show route map, and we do this route map leak permit 10 match prefix, no, match IP prefix, no, address prefix list, right? Prefix list, and we specify this prefix list, and show route map again, route map, and show run a pipe section route map or prefix, IP prefix list, alright, and route map leak permit 10 match IP address, should be alright. Now go to R6 and we do show IP route again. Now you see, right? So we have default route pointing to 1, and we still have this specifics 5555 through router 4. We have this through router 4. We have this through router 4. So we still did not solve our problem completely, but we did the first step. And let me add this to our solution. Where is this? On R4, and pipe include show run pipe include interface or summary. Right. Now let's go to R6 and let's try to telnet to 5555. Oh, sorry, of course not telnet, but traceroute to 5555. Okay. So first of all, we can traceroute. Now we go this way. 4125. Alright. What about others? Can we ping? Can we ping? Ping 5545? We can ping. Can we ping 55? We can ping. How about trace route to 55? We use the same way. Alright, so this sounds promising. So we still need to go this way. Sorry, let me change color. Go this way, not this way. What should we do? Remember, here we have a RIP, and here we have no routing protocol. Let me go to R3 and show IP route 5555. And from R3 we choose really strange paths. Like we go to 4 goes like, what does 4 say? 4 goes to 1. Sorry, you can't see with this color. We go like this. So, but we want from 3 to go directly. So, what can we do? So on R3, let me show run section route. It's really interesting how it's pre-configured, and this is like hint for us. There are different ways to solve this, but there is pre-configuration that could help us to do it. So in some CCA labs I also encounter this, like when you need to change something, like, I don't know, maybe metric for route, or to prefer one over another, and I would find like configured route map or access list with the like IP addresses that were already the same ones as I had to change. So it's like in access list or route maps there were already prefixes that I needed to change some attributes for. So it was like useful pre-configuration for me, like a hint. And here we have the same thing. Look at this. IP route 5555 through 5555, right? So what does it says? Like we will go to these prefixes via this, but we go via to this. Can I trace route, by the way, to 5555? Yeah, I can, and I go 44125. So it says that there's static route, right? Which points us to 5555. But we can't see 555 as directly connected here, right? So it's unnumbered. There is one small thing, so that default encapsulation type here is HDLC. If we change it to PPP R3, you'll see that route is directly connected. So let me show you this. R3, look at this right now. Show IP route 5555, we go via EIGRP 100 to 4. Now let me change first of all, let me verify that serial interface configuration is right. We do show IP interface brief, right? So we have here serial 11 with IPN number to loopback 0, and the same thing on router 5. Show IP interface brief. You see that this serial is down, so of course we won't be able to reach it in the first place. So let's enable it. Conft int serial 12 no shot, right? And I will add this to our solution. On R5, interface serial 112 no shot, right? Okay, let's go to router 3 again. Does it change anything? Oh, sorry. No, we still go to 4. So let me change encapsulation type as I told you. So we go conft interface, I believe it was 011. Let me verify this very quickly. Yes, 11. Encapsulation PPP. Do the same thing on router 5. Conft interface 1/2 encaps PPP. Right. Now look at this. Show IP route 5555. You see, now it's directly connected. So PPP by default installs host route to the other end. So we see 5555 as directly connected. So I will also add this to our solution. Here we have encapsulation PPP, and on R3 we have interface S11 and encapsulation PPP. Alright, now let's look at show run section route again. Now let's do trace to 5555. We go directly to 5. So previously we went like this and do the same thing for 55 55.1. Alright, we still go in another direction. Why is that? To show IP route. We have static route, right? We have static route, but it's not specific enough. Alright, so we have static, but this one is more specific, and it goes like this. Like this. Okay, there are also let me think about that for a sec. So here we redistributing. I wouldn't like to go with static routes here. Alright, what we could do? We have here specifics, here we have static. Let me do this. This, when we redistribute, let me check if... No, it's alright. Here, when we redistribute, so we could do this. On router 5, we could enable EIGRP here on this link, on router 5, and on this link, not on this link. So, and on this, so all this route will be EIGRP internal. What else could we do? Well, here, and probably that will be the way that I go with. What else could we do? Here on R2 we could filter redistribution. So I will say that to EIGRP I don't want to learn about this one 1111. No, we need this one and this one. That's actually even nicer solution. Let me do this. I will filter these two routes here on the redistribution boundary. From here I will disable these routes, right? On R2, if we show run section router, we have this. Here you can see roadmap and filter to filter no, let it be filter. Alright, and I have to configure this roadmap filter, and I will say deny 10, and I will match IP address prefix filter, and I will say roadmap filter permit 20. So what I'm doing here, I will block subnets defined in the prefix list, and then I will permit anything else. So now I have to define IP prefix list, a filter, we permit 10. Now I can just go like this, permit 5555/32 and /32, right? Should work right now. Let me go to to R3. And previously 3. See, we traced 5555, 55.55.1 through 4. We do the same thing again. Trace 55.55.55.1. Now we go directly. And if we change it to 2, now we go the same way as we did before. Why? If we show IP route, you see we don't learn 55.55.55.1 anymore. Yeah, and 5555 is directly connected. Alright. Seems alright. Yep. Okay. Now, so R3 going to 2.1 like this. Which way is going R4? Show IP route to 55.55.55.1. Subnet not in the table. Show IP route 0000 0000 known via. Okay, it was locally originated. Right. What's the problem now? If we trace, it should not work. If we trace 5555, it's working. So, and if we go to R6 and we trace 5555, we're going like this, so it seems exactly as we wanted. And if we trace, it should not work. 55.55.55.1. Yeah, we go to 1 because there is default, and then it says sorry, I don't know how to get there, unreachable. Can we get to 2, for example? We should, because we're redistributing here. So what's the problem is that on R3, so let me clear this. On R3 we have a static route pointing to this static route. Okay. Where is it? This one. Static route. So we should redistribute it into EIGRP so that R4 will this static R4 will learn this route, alright? So let me go to R3, the router EIGRP 100, and we redistribute static with seed metric, and it is okay. Now it should work. We go to R6, we trace again. This is not relevant, we does not care about point 2, we care about point 1. We still go the wrong way. Why? Oh, okay, I know why. So remember here we did leak map, but we did not permit the static route. So let me go to R4, show route map. No, show IP prefix list. Right? See, we have here specific subnets. And I actually can rework this. Because no, I can't do that. Let me think about it for a moment, because we will lose this specific route if I do what I wanted to do. I don't have this static route anymore. Okay, I really need this static route. The problem is like this here. I did here leak map. No, let me go to R4. Show IP route. EIGRP. And we have here we have static route. Yep, static route. Pointing to 3. But we did not specify this route in the leak map, so we can't announce it to R6. Right. Plus, we won't see this specific route, and we will break point 1. So what I will do now, so on router 3, to modify configuration for we could here define static route to 5555.1.1 to here. then we will distribute it, then we will permit it. But from my perspective, it seems that we will break this rule. So we will have impact on routing and it won't be EIGRP, right? So let me show you that this is the valid solution first, and then I will show you what we can do. How can we do it in another way, right? So yep, show run section. See, it's got to 1 to 4 to 3 to 5. We go to R4. No, sorry, to R3. Show run section. No, IP is include IP route. Of course. And I will do IP route to 55.55.55.1. To 55 to 55 to 55 to 55 5555. Okay. Yep. And now if we trace again, we go as we intended. So this is one solution. And from my perspective, it breaks this rule, so not really good. Let me show you routing table on R6. Show IP route. So we learned this route from 4. And let me show you this trace route to 55.55.55.1. Goes like 4, 3, 5. 2, 2. Goes 4, 1, 2, 5. And to 5, 5, 5, 5. We go 4, 3, 5. So as you see, we indeed like solve this problem, but we break this. I don't know, not really good. I will show you another solution right now. So what else can we do? So I would extend EIGRP domain here. Right, so we have EIGRP domain like this. I would add this link, so with this IP address, and I will enable it for 55, 55, 55.1. Probably no, that should be fine. Right, so let me do this. I will revert some config back. Like on R3, I will delete this. On R2, I delete this too. We don't really need this anymore. So to delete this, I need to show IP prefix and IP prefix list permit filter. No IP prefix list filter filter. Oh, we don't need this anymore, right? No IP prefix list filter. And prefix list filter 0000 less or equal than 32. So I basically enabling no prefix list. Show run section roadmap. And I will do this. Conf t no route map. No route map filter permit 10. So I basically redefine this route map to enable all routes. So show route map. Okay. Now okay, what did I write here? Should be fine for now. And on router 3 we show run section router. I will delete this as well. Router EIGRP 100. No. I will network. I will enable it on 3.3.3.3. Zero, 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 zero. And on R5 conf t router EIGRP 100. I will enable it on 5555 0000 mask. I will enable it on 55.55.55.1 000. Right. And on router 3 I will leave it like this, does not matter. And if you do on R4, if you do show IP route, we shall learn about this specific prefix from 3. Right? On R3, if we trace to 55.55.55.1, we go directly to 5. If we trace from R4, we go to 3 and to 5. And from 6, we go to 4, to 3, to 5. Correct. And if you go to 2, we go another way. Okay. So I enabled on this link and on .1 link EIGRP. So I extended the EIGRP domain here. R4 learns about this specific prefixes through 3. About other 55 prefixes, it's learned like this. So, and on R6, if you show IP route, you see that we have D internal. So with administrative distance 90 through 4 for 1. For 2 we learn it also through 4, but then it goes this way. So again, trace 5555, and I should do it from loopback 0, right? From source loopback 0. Yes, I should do it from the loopback 0. You go to 4 to 3 to 5. I go to 55.1. I go also to 4 to 3 to 5. And I go to 55.2. And I go like this. Now we fix everything from my perspective. So I'll put check here, and I will add here to the solutions. So on R3, on R5 I would router HTTP 100 network 55. Why do I type this? I can copy paste it. Like this. And on R3 show run section router, do like this. Alright. There is also interesting one point I would like to show you. This one. Let me refer to diagram so you will understand this. Why is this route is internal and this one is external? We announce them as in the same way, but why is it happening? Well, on R3 we see this as directly connected, and there is also redistribute connected on R3, right? See here. And if we show run section route map, we match interface loopback 0 and serial 11. So we take these two addresses and redistribute it. Now it becomes the external. Even though this IP address is advertised like the internal, on R3 there is choice between the external and directly connected. So directly connected of course wins, because ID is 0 for directly connected, and for this ID is 90, so that's the reason. So if we remove distribute connected, and we look on the routing table of the 6 again. Oh, okay. So we will I will revert this back, or no, we could do this network 555555000. Then we will announce this 5555 here, and now R6 should get it. Now indeed we see that we lost this DEX for 5555, but it does not change anything for us, so I will revert it back. And alright. And there is only one problem left. R5 should prefer serial link to R3 for all traffic and leverage link to R2 as fallback. Okay. So what do we have now on R5? Show IP route. Basically, we solved this problem, and let me explain to you how. See here, serial 12, serial 12. Where we are going to. Okay, we should fix only this. So, as you see, for the most traffic we already prefer serial interface instead of Ethernet E025. Only this is left. Even there is a default static route pointing to 3. Let me do trace route to this destination. Trace. We go like this. And we want to go like this. And let me go to R3. Show IP route 1111. We go to 4. As external. To R4 is external, right? Trace to 1111. We go to 4 to 1. screen. So this is interesting. So it seems that okay, I see the problem. So this one, let's go to R1 and show around section router. We redistribute connected, and if we show roadmap, we match interface loopback. So this one is redistributed out, so and it goes like this and this. As because it's redistributed, it's the sorry, let me change red DX 170, and here we have DEX 170. Then here we have redistribution from EIGRP to RIP, so redistributed like this, and it becomes RIP 120. This route goes like this, and we see it as DEX 170. Let me show you this. So if we go to show IP EIGRP topology for 1111 255 255 255 255, you see we received this route from 3. So the only problem here is like administrative distance. So what I will do, I will lower external administrative distance for this route. Let me do this. Conf T, because we can't increase administrative distance of RIP, because we can't influence RIP in this lab. We go to EIGRP process and we do this distance EIGRP. For internal routes, let it be 90, and for external routes it will be 119. Okay, and if we trace to 1111, now we prefer the path that we wanted to, right? So we show IP route, and you see we now prefer this route because AD is 190 versus 120, so this is preferable. Yeah, so the only interface that the only traffic that we are sending to like via this link is traffic for this subnet, so to this IP address, to maybe another IP address. So it seems that this problem is solved as well. So and before we wrap up, let me include these changes. So on R5, on R5 router EIGRP 100 and distance EIGRP 90 for internal, 119 for external. That's it. Right. Okay. So let me double check each ticket now, just to make sure that we did not broke anything. Okay. So let me clear this. Go to warn. Make sure R6 learns specific routes. Show IP route. I see this. I also see 10.1.25 this and this. Check. Telnet to 1111. Open. Okay. And if we shut down the interface, if we telnet again, works. So over 2 passes it works, so I would say it's check also. Oh, sorry. Sorry. I did not do trace. Trace to 1111 works directly. Conf T, now we shut down the link. Shut and trace to 1111. Of course, I checked from the wrong. I should telnet from router 6, of course. And let's start again from the first point, because I checked it on router 1, not on router 6. Show IP route EIGRP. Okay, 5555, 10.1.25.0 and 55 all networks. Right. Now I can check. Telnet 1111. It works. If we trace to 1111, it goes directly via link between 1 and 6. If we disable link, shut, and we trace again, so there was some convergence process. So we go to 4 to 1. If we telnet, it works. So don't forget to enable interface again. No shot. Should leverage primary default route to next hop 10.1.16.1. Okay. Show IP route 0000. We go to 10.1.16.1, right? If we disable interface, shut, and we do show IP route 0000 again, we go to 10.1.46.4. Seems alright. Enable interface again, no shut. Must be able to ping from R66666 to R55555 and 55.55.55.1 make sure we go to from R6 to R4 to R3 to R5. Okay, if we trace 5555 and we source trace 5555 and we source loopback 0, we go to 4 to 3 to 5. If we go to 55.1 source loopback 0, we go to 4 to 3 to 5. If we go to 55.2, we choose different paths. Okay, we go to 4 to 1 to 2 to 5, but it was not required. Okay, check. R5 should prefer serial link to R3 for all traffic and leverage link to R2's fallback. We go to R5, we show IP route. Okay. Through serial 1, 2 for all destinations except directly connected, except this. Right, so if we disable that link, serial 1, 2, if we shut it down, we show IP route again. You see, now we learn all these routes via RIP. Could we, I don't know, ping 1111? We did can from loopback 0. We can't do it from loopback 0 because it's not announced to RIP. Can we ping 6666? We can. Seems alright to me. Just double check one thing. We actually should be able to ping 1111 from loopback 0 because we have here network. Why we can't do this? Show IP route 5555. We have route from 2. Okay, so it was like temporary issue. We did this again. We can do that. Okay, very nice. And don't forget to enable interface again, which we broke. Okay. Int no shutdown. It's a very last check. You see, now we have all these EIGRP routes through 1/2. So as you see, we solved all the tickets, and I think we are done here for today and for this lab. thank you all if you listened so far till the very end, and I hope I will do the next video tutorial next week after the lab about OSPF. I hope it will be as challenging as this lab was, and please let me know if you have any comments or suggestions for my videos. It's just my first attempt to record a video, so probably you like something or you don't like something, and I would like to know about that so that I could make these videos better. So thank you very much, guys, and until next time.